Hi, I'm Liraz, covering for him today, and this is Drol Dirosh. We both work at TabooKey, and today we're going to be talking about what's next for the gas stations network. Um, so, what we're aiming for is to remove the roadblocks to mass adoption of Ethereum. And we believe the key to doing that is going to achieve the same type of user experience that everybody's used to with Web 2, but for Web 3. We don't think that the wave of mass adoption is going to come from people suddenly being converted to decentralization at an ideological level. So it has to be easy. And once it's easy, it also has to be secure, especially if you're going to be putting a real money into it. And if it's not decentralized, then it's not really a good fit for the ecosystem that we're building. There are many problems that can be solved in a centralized way. And this ecosystem is really interesting for problems that can only be solved in a decentralized way. Okay, so this is a screen full, but it's sort of showing you a roadmap for what we've done so far and where we're going with this. So essentially, with a gas stations network, for those who are not familiar, we've created a toll-free road to Ethereum. This is right now live on mainnet, but it does only support GSN-aware contracts. And the key principle of it is just like when you connect to a server, you're not paying the server fees. Someone else is paying for that. And that makes onboarding users to a new application a lot easier. In this centralized world of blockchain, you have to pay for from the first interaction with the smart contract, and sometimes that's a big hurdle. So the first time I interacted with a Ethereum smart contract, it took me a month to get ETH to pay for the gas for my first transactions. So the GSN changes that. Now you can implement all sorts of models. And the next step that we're going to be demoing today, we're going to explain a little bit how that works, is the GSN sponsor model, which we have a live demo of on mainnet. And this essentially extends the toll-free road that we've built for the gas station network to any contract, including unmodified contracts that are already deployed. And we're also going to be talking about what's next, or working on right now, is after you've built this toll road and you've connected all the applications to it, well, how do you get real users on board? And essentially, we're building a secure vehicle that doesn't require the user to know anything about key management or endpoint security, and also creates a nice, sustainable business model for wallets and infrastructure providers that is healthy for the ecosystem. So just a quick recap of what the gas station network is. That onboarding was a mess. Kind of looked like this, many steps, especially the KYC AML to get that first ETH to pay for gas. And it's even worse because many potential users that would benefit a lot from having blockchain infrastructure don't even have a bank account. This is a big problem in many parts of the world where social infrastructure is not that good. Maybe you don't have the type of financial infrastructure that we take for granted in the West. So the current onboarding methods sort of exclude large portions of the world. And with a gas station network, the onboarding experience can be like this. It's very direct. It's seamless. There's a direct path. You don't need to get anything in advance. You don't need to pass KYC and AML. It just works. And we're live on mainnet thanks to a range of supporters. Thanks to the Ethereum Foundation, Consensus, Zeppelin OS, Maker, our friends at Portis. We also have a really nice demo on top of that powers the burner wallet infrastructure, provides gas-free transactions for that, and that's been working since January. So what's next? So this is GSN++, and basically we're building an engine for mass adoption. So what does that mean? Well, without the GSN, a user connects directly to Ethereum, but you need the ETH to pay for gas. With a GSN, it's a layer 2 network. Anyone can run a node, just like the blockchain, and you interact with that. Essentially, these are web relays that are registered on a smart contract and you pick one of them and you relay transactions through them. And then the contract that you're interacting with can pay for gas fees and maybe settle with you some other way. But it has to be aware. It has to be GSN aware. You have to modify the contract in certain ways. So the next step is extending this to work with any contract, including existing contracts. And we do this by essentially creating this centralized GSN sponsor contract. Now, what it does is when you're communicating through GSN, you don't say, "Oh, I want to go to a GSN aware contract, which is the final destination." You say, "I want to go through a GSN sponsor," and then the sponsor sets up a sponsored proxy for each user, and then from that, you're reaching out to the final destination, the contract. So this is interesting because, well, first it supports unmodified contracts on mainnet. So this is immediately applicable for any contract, and we're going to be demoing that today. It also creates a very interesting business model for wallets and infrastructure providers. So on the wallet side, you can do things like charge users $5 on a credit card for $4 worth of gas. You don't need to have them pass KYC and AML for that because you're not transferring them ETH. You're just paying for their gas fees. So that's nice. And what we're going to be demoing today is an example sponsor contract that allows you to pay for gas in DAI. You can do that with any token. And a nice use case that this enables that we're not going to be talking about because it's a little bit more advanced, but is very interesting, is decentralized privacy mixers. There's some technical problems that the GSN sponsor model allows us to solve with that and basically get that into production very quickly. Okay, so this is the demo we're going to be doing. Paying for gas with DAI, an existing contract, no modifications. And why would you want to do that? Because ETH is kind of volatile. So a lot of people, they prefer holding their funds in something that's stable. And this would let them pay for their gas with DAI. You don't need another token. Okay. And the way this works, wait, there's one on, just like, sorry. Bring it back, okay. So the way this works is you have a GSN DAI sponsor contract right there in the middle, and it's not subsidizing the cost for its users. What it's doing is it's accepting DAI from them, and then it swaps in one atomic transaction. It takes the DAI, it uses Uniswap to convert that into ETH, and then the remainder it transfers back into DAI and gives it back to the user. So you're just paying for gas in DAI, any contract, right? Right.
Okay. Thank you. Can you hear me? Because I can't hear myself. Okay, so this is a demo app. Hope you can see it well. What we can see, this is a simple wallet application. Our account, as Liraz says, is a proxy account. This is our proxy account. If you go on Etherscan, it's a demo on mainnet. We can see this is an account that, yes, it does have some BAT, it does have some DAI, but it doesn't have any contract, doesn't have any transactions. It's not a real account. This is, we see how many BAT and DAI it has, and I want to make a transaction with that account. So I'll try to transfer, wait a minute, I want to transfer to this account. I'll just copy its address. I want to transfer 1 BAT. So I perform a transfer operation. I put an address and the amount I want to pay. One thing I want to show beforehand, as we said, this is a proxy account, and this is our owner. The owner is my MetaMask account. This account, we see it here, and this account also doesn't have any ETH, anything. It's just a signer account. So, okay, let's perform a transfer of 1 BAT. I put in 1 BAT. And, sorry for that. It's UI glitch. I'm sending 1 BAT. MetaMask asked me to pay. Again, this is my account. I don't have any ETH. All I have to do is sign. I signed a transaction. This is a transaction that it sent to a relay. And, okay. Great. Market price is too high.
Can we increase the gas price?
I increased the gas price. This is insufficient. 10 DAI is not enough for it. So I'm unable to demo it on mainnet.
I'm just going to switch to Rinkeby because there's a lot of stress on
Yes.
mainnet right now. And gas fees are high.
Even though it's Sunday, it's a bad time for demo. Okay, this is Rinkeby. This is not a real DAI. It is the same token. I will transfer. I will transfer 1 BAT. Put in the amount I want to transfer. I'm now on Rinkeby. I send a request. Now the request is sent. It's not a real Ethereum transaction. It's a transaction to the relay. It is signed by the client. The relay will put it on chain on our behalf. It goes through the sponsor, and the sponsor, even though this is the gas price, it took some DAI from my account in order to pay for this transaction. This is Rinkeby. It's much cheaper. So we can see that my DAI amount reduced. And if we look at the account, on my account on Etherscan, yes, it's a Rinkeby account now. You can see I never had ETH. I still don't have ETH. I have 1 BAT less. And if we look, just a second, let's look at the transaction we just created. This is the transaction on chain that was created. It was created from a relay address. This is not my address. And it performed actually 3 token transfers. The first is the full gas price in DAI that my account had to pay to the sponsor. The next is the actual transaction I wanted to perform, which is send 1 BAT. And then I got refunded for the excess in DAI that I paid because it didn't cost this much. And you can, so this is eventually what I paid. If you come back later, I will try it again. I'm sure it will work in the mainnet, just as it worked half an hour ago.
Yeah, we tried this a few minutes before the presentation, and everything worked. But this is the nature of Murphy's Law and demos. All right. So we will get the gas optimizations sorted out when this is not just a demo. But going back to, so what is the challenge and the opportunity? So the GSN sponsor contract, it's creating a proxy for each of the users. Because if we're talking with the end user, then the end user doesn't have any ETH. So it wouldn't be able to own any DAI directly because it won't be able to interact with the DAI smart contract. So you have to set up a proxy. But then you have a problem. Because if you have a naked user proxy, which is just a smart contract that's proxying accounts, you need key management to control that. And there's a big problem with key management in that it's not necessarily very intuitive to everyone, but essentially you have the secret that you want to prevent from being stolen. What do you do when you don't want something to be stolen? You create as few copies as possible. You make the copies really hard to access. You encrypt them and so forth and so on. But you also don't want the key to be lost because that's equivalent to burning the asset. And when you don't want a secret to be lost, what do? You create many copies, and you make the copies easy to access. So the engineering strategies for not having the key stolen, not having the key lost, are mutually exclusive. And really, when you say, oh, my key is secure, you mean both. There's a lot of cyber security expertise required in getting the balance right. It's not a trivial problem, even for experts. A lot of funds have been lost, unfortunately. So we want to get to a different model. We don't have key management as a problem in online banking. And why is that? This is because we have people in the loop, right? Even if someone steals your online banking password, they can't just steal your life saving. This is because if there's a suspicious transaction or a high-risk transaction, you're going to get some sort of verification call from the bank. Maybe low-value transactions not. Like you can just swipe your credit card for $100, but for $5,000, you will get a verification call. And if you're trying to wire out your entire life savings, you may need to present yourself in person to the bank, your bank account manager. But then the tricky thing is you have the bank in the middle, and it's a counterparty risk. And if this was crypto, it would be holding your private keys. That's not a good fit necessarily for the use cases that we want to support. But you can achieve the same thing by transferring the asset to the control of a smart contract that implements this security policy that would otherwise be performed by the bank. So this is a new technology, a non-custodial technology called safe channels that keeps your assets secure even in the worst case scenario happens and your private key is compromised. And we connect your user proxy to that. What we implement on the is an intention verification process that's proportional to the risk. Transactions are reversible within the delay period. The delay period is also configurable to be appropriate to the risk. And you have secure recovery. The end result is that you don't need any key management or endpoint security expertise. And you're on this toll-free road to Ethereum. It just works. It's like a Web 2 user experience, but behind the scenes, there's a lot of back-end interesting things that are happening. So you get security, but without centralization. So how does this work? So on one side, you have an owner. Essentially, a safe channel is like this magic pipe that connects an owner to assets on a blockchain, and it only lets through good operations while blocking bad operations. But this magic does require a bit of a trade-off because we're putting people in the loop and we're verifying the intentions. You can't do that in real time. So essentially what you do to protect against threats, you have this contract that is in direct control of the asset, and it's implementing a delay period. So it's like this logical conveyor belt. And the delay period gives us time to perform an intention verification process. So essentially, we're plugging into the safe channel participants that are acting like intention oracles, and they have the power to block, within the delay period, a bad transaction from going through, but not necessarily the power to initiate a bad transaction. So how do they know what's good and bad? Is they reach out to the owner, and they ask. They see, oh, there's this, pending transaction on a safe channel. They're monitoring the address. Is this what you intended? And that could be a video call, for example, with the owner. And you take that video call and you hash it and you post it online on chain as proof of intention. So let's say there's a mismatch and the owner says, no, I didn't mean for that to happen. Then the safe channel contract gives the intention oracles the power to veto the transaction. It never confirms. So, at a high level, you have the user and you have any contract, and through the GSN, you don't need any ETH because you're communicating with that instead of with Ethereum directly. And thanks to the GSN sponsor model, you can now set up these secure user vehicles for each and every user. And we're going to work with a range of wallets and infrastructure providers to make that a very seamless user experience. And that connects users to any contract. And it's very easy, it's very secure, and it's still decentralized with no central points of failure, thanks to the magic of smart contracts. Any questions? I think we have a little bit of time for that. Can you explain the technical details of how a sponsor works?
How a sponsor work? How a sponsor contract work? Okay. First of all, are you aware of the GSN model? Okay. In terms of GSN, the sponsor is a relay recipient. That is, the relay, when you create a transaction on chain, you ask him, can relay, will you accept this request? It will answer yes. And then when he gets the request contains the address of the proxy contract and the actual transaction to send through it. It verifies that the caller is indeed the owner of this proxy object, which is very important because the proxy object is unable to do it by itself. The proxy object can check the owner if it is called from an external address, but here it is called from a relay hub or from a relay. So it's a GSN aware in order to check the owner. And then we pass the request and it called executes. It's a standard proxy account.
At a high level, what's happening is that you're essentially creating a satellite contract that's GSN aware. And then this satellite contract just sets up this proxy for the user, and it makes sure that someone is paying either the DApp side or the user is being settled within some token, or maybe on the user side if it's a wallet, someone is willing to sponsor it. And then you can just proxy, essentially the proxy address, you're just putting, imagine you're putting a request in two envelopes, right? One envelope is to the gas station network, and you're saying address this to the sponsor contract, And then once you open that envelope, you have another one. Okay, so my final call is to this outside contract. So it's like the series of envelope that you open. And this would usually be implemented just inside a regular, like a GSN-aware contract, but you don't want to change the contract necessarily. So you're just like doing it in a satellite. You're putting all the logic inside the satellite. So that's at a very high level.
One important thing to notice is that not that you don't modify the target contract, even you almost don't modify your application. You put in a sponsor-enabled provider, you just change the provider, wrap it, and then all your requests go through a relay.
Thank you, everyone. Just reach out to us if you want to ask more. We'll talk more about how this works, and thank you.